Um, we have today a great speaker. We have Greg from Amazon Redshift. He's going to give us a talk. And at the end, if our time allows, we'll do a Q&A session. And I'm going to post a link in the chat. So we actually have a questions.clevertech.biz forum where you can put questions as we go along. And Greg can answer them if time allows. I ask that everybody please mute while Greg is speaking so that we don't have a lot of background noise. And yeah, feel free to use the chat. Great. Welcome, Greg. Thank you so much for coming.
Great. Thanks, everyone. So I'm Greg Kerala. I'm the Business Development Manager for Amazon Redshift. I also have responsibility for Amazon QuickSight, which is not part of today's conversation, but happy to take questions at the end. A little bit about myself. I've been at AWS for almost 2.5 years. Before that, I was part of the business development team at Intel for big data. Otherwise, most of my career was at Oracle, where I was part of the database and Exadata team. And so I think I have about, maybe 35 to 40 minutes of slides, but, we definitely want to make sure I'll try to go through some of the slides briefly as possible to, open up time and have, plenty of time for Q&A at the end. But of course, anytime if you have questions after this, we can share my PowerPoint deck as well as my email if there's follow-on questions I could help with. So here's kind of what I wanted to cover today. Just, a quick overview of what Redshift is, and then focus on just some use cases to get everyone a sense of how customers are using Redshift, and then talk a little bit about the technical benefits, and then we can either through the chat or if it's possible through the audio to leave time for Q&A. So in terms of our big data portfolio, so one thing I'll just say is that if depending on your familiarity with Amazon Web Services and maybe just cloud computing in general, oftentimes we think of compute and storage as the fundamental building blocks of cloud computing. So, reduce or eliminate capital expenses, trade it off for operational expenses, only pay for what you use. And over time, customers came to AWS and said, we understand that we can install our software package of choice on compute and storage, but we'd like to, move up a level where we can think of, database as a service. Meaning that, AWS is responsible for not just the compute infrastructure, but also the installation, configuration, monitoring, backups, patching, all the skills that are essentially infrastructure and below. Then when we think about database, we want to be specific in terms of if it's transactional, and if it's transactional, is it relational or non-relational, or is it analytics focused? And then, of course, is it Hadoop ecosystem. So I don't plan to go through all the different components here, but definitely from streaming perspective, we have Amazon Kinesis. I assume most folks are aware of S3 as sort of this idea of the data lake with S3, where raw data typically lands into S3. If it's transactional in nature, we have systems like our relational database service, and including Amazon Aurora. On the NoSQL side, DynamoDB, then Elastic MapReduce is our managed Hadoop service. And so there's lots of varieties of architectures that oftentimes combine these different services into an overall solution. But as far as today's talk, we're just going to focus on Redshift, but we're happy to come back and address other components as interest builds. So, in terms of just a quick overview of what our Amazon Redshift is. So first, it's a relational data warehouse. And I'll go into a little bit more details, but it fully speaks ANSI SQL. It's a column store, so data is stored into columns, not into rows. And it's massively parallel, meaning that you can horizontally scale out. So you could start as small as 160 gigabytes and go all the way up to multiple petabytes of data. And it's a fully managed service. So maybe you say fully managed with an asterisk. So you definitely still need a database administrator, and I'll talk about some of the skills that are required for Redshift. But this DBA is really just focused on the schema and the user experience, meaning query performance, and not the underlying infrastructure. And then, what oftentimes, leads customer interest in terms of Redshift is, quite honestly, the price point. So, if you kind of look at a comparative system like Teradata that has, a publicly listed price list, it's not unusual to see for the published price list for Teradata to be something like, $64,000 per terabyte. With Redshift, it could be as low as $1,000 per terabyte per year. And so we often say that, customers come to Redshift because of the tremendous cost savings, but oftentimes stay for the performance and the gain they have in terms of innovation that it drives through analytics. So if we look at, kind of this legacy view of data warehousing, obviously, multi-year commitments, potentially millions of dollars of investment. And what this really means is that, if I make a decision in terms of analytics today with the traditional platform, I essentially need to, answer questions a year from now, 2 years from now, all through that funnel because I had made such a large investment. And with Redshift and AWS in general, we want to really unlock innovation such that, we are not sure what the business will look like a year from now, 2 years from now. Therefore, we shouldn't, make big expenses purchases that will, make all decisions funnel through that single stack. And so we want to have a more flexible architecture. So in terms of our view of data warehousing and the common use cases, which I'll discuss here in a bit more detail in a second, but we kind of break this out into 3 broad categories. So, the first we'll say enterprise, which, could be, small, medium, large-sized customers, but these are, customers that already have a data warehouse, whether it's Netezza, Oracle, Vertica, on and on, Teradata. And so what often leads them to Redshift is, of course, as I mentioned, it's oftentimes can be 10 times, if not greater, less expensive. It's easier to provision, and then the database administrators now just focus on end user experience in terms of query performance and not the underlying infrastructure, not worrying about backups and all that super critical stuff, but that's all now part of the service itself. The second category of use cases we see are customers with what I'll call big data, where, yes, customers, find like Hive and, all kind of different SQL on Hadoop technologies, but where the primary interface to this new big data technology is some kind of business intelligence tool that has a requirement for ANSI SQL, or where the analysts are just more familiar with SQL language itself and don't want to have some of the limitations that traditional Hadoop or SQL and Hadoop technologies bring. Oftentimes they find Redshift to be a compelling choice where the data is more structured and I can organize the data into relational tables. The third set of category of use cases, we'll call it software as a service, and this is where applications that are deployed onto AWS that are serving a particular business function that might need to embed analytics. And so they can essentially use Redshift behind the scenes as part of this software as a service offering and just focus on their application, but still allow the deep analytics driven through Redshift. So I'm just going to kind of walk through a couple of use cases first before we get into some more of the technical things. Many of these use cases have much deeper write-ups and videos with customers actually talking about it, but I'll just kind of highlight a few. So the first is, Boingo Wireless. So if you've been to airport, you should be familiar with Boingo and the number of hotspots they have. They had a traditional Oracle data warehouse, and they needed to make some decisions in terms of the amount of data and the growth of their business. And so they evaluated Oracle Exadata, SAP HANA, as well as Amazon Redshift. And, what they found from their experience and their kind of looking at different options that, it really validated some of our claims in terms of the cost savings as well as the performance gains that they were able to realize by leveraging Redshift. So not only is, Redshift a fraction of the cost, but it's actually, significantly outperformed other data warehouses, and I'll get into some details of how that performance gains are actually realized. Oftentimes you get questions about how our retail parent, Amazon.com, uses Redshift. So this is another migration from Oracle data warehouse. So obviously, if you're familiar with Amazon, you'll understand, customer behavior is super critical. And just given the, existing solution, which was, mostly an Oracle RAC data warehouse as well as Hadoop. And our internal analysts just were not able to get the type of performance out of the data warehouse. And so we now have, actually the slide here says 1 petabyte of data, but it's actually grown to almost 2.5 petabytes since this slide was created, and they're able to get very effective query performance time, particularly compared to what their old system, where it made it take days, if not weeks, to get data out, as well as comparisons to previous Hadoop-based Hive clusters for joining data. And if you look at some of the, obviously we have more than just one Redshift cluster internally. It's actually 64 different clusters with over 13 petabytes of storage accumulated, with the largest one being about 2.5 petabytes. But even across all these systems, because Redshift is a managed service, internally our database administrators at Amazon.com, there's only 2 of them that manage this complete environment, because once they design the schemas and then they're able to monitor performance, they don't have to worry about the infrastructure provisioning. So there's tremendous productivity gains by not just running Redshift performance, but also from a IT staffing perspective. And then oftentimes we look at this idea of streaming use cases. So we wanted just to use an example that we could all sort of relate to, where perhaps I want to ingest Twitter Firehose, land it into S3, and then put it into Redshift for analytics like sentiment analysis. And then this is the idea that I was talking about earlier, where we really want to think about analytics as driving innovation, and how quickly can I stand up a test environment, validate some results that's based on a new data source, and then do it in a real-time or streaming type environment. So one of the things that can drive innovation, of course, is not only to being able to capture, Internet of Things, or in this case, Twitter data, but be able to do so in a very cost-effective manner. So here, in this example, we have capturing 500 million. Anyhow, so in this example, we just want to think about, if I had an Internet of Things or devices, mobile devices, gaming devices, in this case, we're looking at generating 500 million tweets per day, so it's about 5,800 tweets per second. You want to use Amazon Kinesis, which is our managed streaming service, to essentially capture and store that data into Redshift. And then think about what a basic pricing model would be here. So not only am I collecting real-time data from Twitter, but then I'm storing it and analyzing it into a data warehouse where business analysts can now discern trends and understand sentiment from Twitter, but also, broadly applicable across other Internet of Things type applications. And then the fact I could do that for less than $3 per hour, what this really means is that I can now think of our data analysts or data scientists as being empowered to stand up, very rapid tests of new analytic techniques they think can drive value. And for, small, very relatively small investment, you can have an iterative environment where if the test is successful, they can prove out a business case by actually deploying the system. You can deploy it at scale for production use. But probably more important, if you find that this new technique is not as critical or doesn't provide insight, you can turn it off for a very small investment. And this idea of driving innovation through experimentation, I think, is really key to understanding the full breadth that the cloud and AWS can bring for analytics. And so another, I just got a couple more use cases to walk through before we get into some detail, but one of our other larger customers in telecommunications is NTT Docomo in Japan. So they replaced their Greenplum data warehouse with Redshift. And obviously, it's more than just, the call detail records that they're loading, but also personal identified information of their customers. And so encryption and security and access controls are critical requirements, but then it's also a hybrid architecture where their core infrastructure in terms of their telco CDR record collection, of course, is on-premise, and they just use through Direct Connect and virtual private cloud, they're able to extend their analytics framework into AWS to drive a multi-petabyte data warehouse to feed their business analysts that again, have their BI tool running in their on-premise environment. So it doesn't have to be an all-in cloud deployment. It can actually be a hybrid architecture. And there are many cases, such as NASDAQ and other customers that follow the same pattern. So here's just a quick overview of this, high-speed connections and encryption, backup, access controls. And, what's unique about Redshift is that not only do the standard security models within AWS apply, but we've also extended to be able to take into account HIPAA-compliant workloads. So if you have medical healthcare information, PCI data in terms of any kind of credit card information, then of course, because of the data being stored regionally and globally, if there's any kind of data requirements in terms of data sovereignty, of course, if you have customers in the EU where the data cannot leave, we guarantee never to move data outside of a region. And so there are many other certifications in terms of data sovereignty that Redshift can deliver. So the last example I have, and I'll take a quick break to see if there's any questions that popped up, but we find this one to be kind of interesting, again, kind of thinking about Internet of Things or instrumenting non-traditional environments. And this is actually a sushi chain in Japan, Shishiro, that essentially placed an RFD tag on the bottom of the sushi plates. And so the picture here, as you can imagine, you go into the restaurant, you have a conveyor belt of sushi items coming by, and then you pick up the tray or the item that you want to consume it. And it turns out that just that simple act of picking up the item of the sushi tray actually generates 12 separate data points. So some of them, of course, can be the time, the location, the store, the item, when it was placed on the tray, when it was consumed, and maybe some inference in terms of the customer themselves. And all this data essentially gets streamed back, again, through Amazon Kinesis into Redshift for analytics. And so here's kind of a, maybe a simplistic view of this where, this real-time data integration and ingestion through Kinesis and then into Redshift across 380 stores and be able to do some forecasting of demand, minimize food waste, and improve efficiencies. And they happen to use Tableau as the business intelligence tool on top of Redshift. And so this is kind of this idea of mixing real-time and batch updates in a more retail type environment where you can define value for much more rapid analytics. So they're just, I kind of went quickly, but I want to just make sure we leave time. But any questions on those 3 use cases? Redshift? Okay. I don't think I have access to the console right now to look at the questions, but I'll just go on if that works. So now probably what more people are maybe interested in is a little bit of, we kind of had an overview of Redshift, talked about some common use cases in terms of, enterprises, big data, and a little bit about software as a service. So let's just talk about what Redshift, actually is. And so Redshift, of course, it is a relational data warehouse. Of course, you have tables. Tables have relationships between each other. So I think about the SQL client and the leader node. So the leader node is essentially a metadata repository that understands the query execution plan and is a lightweight dispatcher of queries. And you don't have to provision the leader node. You don't pay for the leader node. It basically is a construct that sits between your BI tool and the actual data themselves. And to the external SQL client or BI tool, Redshift just appears as a Postgres database. So you can use the open source Postgres driver. We've also done some optimizations to be able to have our own Redshift driver, which is simply the additions into the open source Postgres driver. So any BI tool that's certified with Postgres, should work seamlessly with Redshift. And we've done some special certifications with some BI tools I'll talk about shortly. But connect to the leader node, and then the compute nodes is actually where the database itself resides. And so Redshift, as I mentioned, it is a column store. This means that if I kind of compare this to a traditional database, let's say Oracle, which is a row store, from an analytic perspective, it's much more efficient to just query the columns. And so analytic queries oftentimes will do aggregates of some kind of functions across columns and not be so concerned about individual rows, such that I might have 100 columns in a table, but if the query only asks for 3 of those 100 columns, I only have to read, those 3 columns directly. And of course, that can directly translate to much faster query response time for analytic queries. And then, Redshift parallelizes and distributes all of the queries, all the data loads, the backup, the restores, the resizes. Those are all, parallelized and handled for you, such that I can achieve that massive parallel processing across, whether it's a very small cluster with 2 or 3 nodes, all the way up to hundreds of nodes in my cluster. And then, of course, Redshift comes in 2 different flavors: magnetic drives, as well as SSD drives, depending upon your workload. And then not only do we automatically and continuously back up your database into Amazon S3, but the per hour charge for Redshift actually includes an equivalent amount of backup space into S3. So if I have a 100 terabyte data warehouse, I have included in my cost 100 terabytes of backup space into S3 for no additional charge, and we continuously and automatically back up your database. So it really alleviates a lot of the cost and complexity of making sure I have a highly available or durable data warehouse. So let's kind of go through a couple of benefits of Redshift to kind of dive deep a little bit more on some of the benefits. So I mentioned that, what really drives performance for analytic queries, and oftentimes it's a reduction of the I/O. And so less I/O I have to do means the less transferring of data, which directly corresponds to significantly faster query response time to the end users. And so the ways that we can drive this less I/O, again, to have that fast query time is first, as I mentioned, column stores. So, again, the example of if I have, 100 columns in a table, if I only query 3 of those columns, I only have to read data for those 3 columns and not the entire row of data. And so that can dramatically improve performance. And then because data is stored into columns and not as tables or not as rows, I can achieve, very efficient compression at the column level. So the column obviously would have similar data types or the same data type, and I can actually choose different compression algorithms based upon the type of data in that column, looking at the compression advisor that we provide as well. So it's not unusual for, on average, getting 3x compression. So if I have, a 9 or say a 10 terabyte data warehouse, I should expect on disk that to be about, 3 terabytes of actual disk space. Knowing that based on your data type, you might sometimes see up to compression levels of 10x. And so that can provide significant cost savings, because now I only have to size my cluster based upon my compressed data size, but also from an I/O perspective, the higher compression I have on the columns, the less I/O I have to do, which again translates to that faster query response time. So in addition to compressing at the column level, if I think about the block size in the Redshift database, so the block size in Redshift is actually 1 megabyte. So every I/O operation operates on 1 megabyte of data. Again, this is because of the analytic nature of Redshift. If I contrast that to a traditional database, like, I'll just pick on Oracle again, usually in Oracle, like the default block size would be 8 kilobytes, and that's because we're interested in transaction processing and not analytics. And so the default, and actually the only setting for block size on Redshift is 1 megabyte. And then for each megabyte of data, we transparently store the minimum maximum value into something called a zone map. And so this essentially allows the optimizer to skip blocks of data that cannot contain the result of the query itself. And so we try to avoid, if not eliminate, full table scans, because we're only querying the exact data blocks that can only contain the result set that's asked for in the query. And then, of course, Redshift at the compute node level has direct attached storage. And so this eliminates the bottleneck of having to go through an interconnect between compute and storage. And we have direct attached storage. Again, it's either SSD or magnetic drives directly attached to the compute, which allows for very fast query execution. So if I choose to deploy a 10-node cluster, and let's say that 10-node cluster will be our magnetic, we call it dense storage type, then that 10 nodes would have 20 terabytes of storage. And oftentimes we recommend having 25% free space. And so this is really where, in terms of where I get started in terms of sizing my cluster, we look at our raw data size, apply some estimates in terms of compression, and then add 25% of free space. And usually that's a starting place in terms of starting my testing, knowing that because you just pay hourly for Redshift, we really encourage sizing through running definitive tests and not through theoretical examples, because again, you don't have to make a large capital expense up front to get started with Redshift. So in terms of this, I talked about this idea of the database administrator still being required with Redshift, and how we can offload majority of those tasks, but there are still a few things that in terms of DBAs or someone technical on our staff needs to consider with Redshift. The first, I talked a little bit about previously, which is selecting the number of nodes and the node type in my cluster. The second, of course, I mentioned, which is compression. So determining the right compression algorithm at the column level, or just choosing our default compression if that's a better choice for you. So those are the first two. So number of nodes in the cluster. Then the second one is the compression type, which I talked about. The third one is just the idea of sort keys. And so I can have up to 8 columns on a table identified as a sort key. And a simplistic way to think of a sort key is that if you're familiar with a system like traditional database, think of them as like an index. Although Redshift does not, maintain a separate index. We essentially have sort keys that can physically define how data is laid out on a particular compute node. And so in the example here, if I have an unsorted table and I had this select count star where log date equals, June 9th, 2013, on an unsorted table, I would actually need to read, 3 separate blocks of data just to be able to, determine when and which block of data has the same result or the correct result. Whereas by sorting by date, the optimizer through the zone maps understands, okay, only one block of data could physically contain that result set, so I only have to read one block of data. So by simply understanding the correct sort key on a table, the query on the right, the sorted by date, we would expect to run 3 times faster, because on the left I had to do 3 I/O operations, whereas on the right I only did 1 I/O operation. So understanding sort keys and the different types of sort keys is kind of critical to understanding performance within Redshift. And I mentioned that we parallelize and distribute both the queries and the data loading, and so the data loading is oftentimes done directly from S3. We certainly have integrations with Informatica, SnapLogic, Talent, other ETL tools, but customers can also just choose to leverage something we call the copy command to directly load data into Redshift from S3. And of course, backups are included and automatic with Redshift. They go to S3. And then one of the unique things I mentioned in terms of how I size a cluster is that I can start off small and only pay for my current requirements. But then if data size grows or number of users grows, I can we do a resize. And essentially what we do is we provision a new cluster for you in the background with either the plus or minus number of compute nodes you've added or removed, and then seamlessly move your data over and then move the endpoint over. And so this resize operation, it can take maybe 30 minutes to an hour where your database is in a read-only mode while we're provisioning the new cluster, but certainly a lot faster than having to install and configure new hardware. We also have a feature called cross-region snapshot copy. So some customers, based on regulatory compliance or just being able to serve data for local customers, will choose to copy the backup from one region to another region, and then only only maintain the backup in S3 in that separate region. So let's say I was running my Redshift cluster in US East in Virginia, and I wanted to store my backup from a disaster recovery perspective in US West 2, which is Oregon. I can just initiate the cross-region snapshot copy command. It just will move incrementals over to Oregon. And then if, I have customers on the West Coast I want to serve for analytics, or however unlikely the event might be of a regional event in Virginia, I might need to switch over to Oregon. I can just go to my Oregon backup and start that from within one command and be up and running very quickly. So not only being able to maintain the backup in S3, but then leveraging the cross-region snapshot copy oftentimes is used for customers for a very cost-effective DR strategy. So I kind of diverged a little bit there in that previous discussion, but so I talked about the 4 keys to driving performance in Redshift. The first is the number of nodes. The second was the compression type. The third was the concept of sort keys at the table level. Then the fourth, understanding is distribution key. So we have 1 distribution key per table, and the idea is I want to choose the right distribution key such that the data is evenly distributed across the compute nodes. So this might be like a partition key in other technologies. We call it a distribution key. And we have many tools and insights into making sure we have the correct distribution key. But what I want to do is make sure that, as I load data at the table level, the data is evenly distributed across all the compute nodes in the cluster such that one compute node does not have majority of the data that could become a blocker in terms of all requests going to one individual compute node. So understanding the distribution key is key, and it basically just determines how evenly data is distributed across the nodes in my cluster. And if I choose the right distribution key, then as I add, go from 3 nodes to 5 nodes to 10 nodes, I should expect the Redshift cluster to seamlessly move and distribute data as I add or remove nodes into the cluster. So I know there's a kind of a long number of slides on benefit number 1, but then the last piece is the hardware optimizations that we've put into the Redshift cluster itself. And so as our friends at Intel continue to upgrade processors, we adopt them into new instance types. For instance, we launched our dense storage 2 instance type that was double the memory, double the compute, 1.5 times throughput from the disk, at the same price as the previous generation. And then, of course, as a managed service, we automatically, patch and upgrade not only the hardware but also your software, and then be able to, drive, significant performance and really, look at the benefits that, whether it's the hardware or the software enhancements, and not having to worry about, hey, am I on the current version or am I on the latest hardware, but being able to, offload that as part of the service itself. So the second benefit then, I mentioned this earlier, is in terms of cost. And so here's just, some basic, decisions around pricing. If you're familiar with AWS, you should know that there's always the on-demand price, which is the highest price you'll pay. And then you can get significant discounts by doing a reservation. And so reservations either come in 1 or 3 year commitments. And for instance, at the maximum discount, if I do a 3-year commitment to Redshift, which is probably most likely what you'd be doing in terms of a comparison to purchasing a system on premise anyways, so a 3-year reservation actually gives you the highest discount, which is 74% off the on-demand rate. So understanding that from the nature of database workloads is usually I'll do some period of testing, determine if Redshift works for my use case, in which case during the testing I'll look at the on-demand price. But then once I kind of validate that Redshift makes sense and I want to go into production, oftentimes going into a reservation will provide significant cost savings for your deployment. So I mentioned this a couple of times, the third benefit, which is, Redshift is a fully managed platform. So again, fully managed meaning at basically the infrastructure level down. So you still need to, think about the schema and sort keys, distribution keys, but, we obviously provide multiple copies of data within a single cluster. So if you lose a compute node, you don't lose your data. The backups are continuous and automatic to S3. As well as when I go to restore from a backup, let's say I want to test out a new group of users that for certain architectural reasons might need their own cluster, or if I want to do some testing for different configurations, I could actually just restore a new cluster from a backup. And if you imagine I have 100 terabytes or maybe a petabyte of my cluster, it certainly will take a certain amount of time to move that backup from S3 into my compute nodes themselves, but we can dramatically reduce that time by doing something called streaming restore. And so what we do is we actually load the metadata into the leader node first, and then almost immediately bring up your cluster while we're still streaming the backups from S3 into the compute nodes themselves. This allows you to start querying data very, very quickly, knowing that if a query comes in that asks for data that's still in the process of going from S3 to the compute nodes, that individual query might be slower, but overall I could start using the cluster much faster than having to wait for the full copy from S3 into the compute nodes to be complete. And so in terms of building out the Benefit 3 fully managed service, the fault tolerance. And so as part of the service itself, we manage and monitor for disk failures, node failures, network failures, any kind of availability zone or even region level issues are handled for you, such that you can always maintain your cluster up and running. Now, there are some techniques we can talk about that, like I mentioned, in terms of cross-region snapshot copy, which can provide regional availability if needed. But essentially, not having to worry about the hardware or the infrastructure can dramatically reduce the amount of overhead it takes to actually manage my data warehouse. So benefit number 4 is around security. So you have a choice when you start a Redshift cluster in terms of enabling encryption. And then you can also connect over SSL. And then, full audit logging access control. So any operation in terms of GDL or DML that can, change the schema, change the configuration, any kind of database administrator activity, end user activity, all of that can be audited and logged. And those logs can be stored into S3 for historical analysis. And we have a number of third-party certifications, including, as I mentioned, PCI. We can include Redshift in a business associates agreement for HIPAA data, like U.S. healthcare data. If you have customers or partners that are required to meet the FedRAMP compliance, and so FedRAMP essentially allows U.S. government agencies to use Redshift cluster, and we have a number of those that are currently using Redshift. So this kind of gives a third-party validation, and there's a much larger list of validations than here on the slide, but we've been very aggressive in terms of opening up Redshift for many use cases and many different industries. So for example, I mentioned NASDAQ uses Redshift in terms of its analytics for its stock trade data, and they actually generate, as you can imagine, their stock trades in their on-premise trading environment, encrypt the data before it leaves their environment, lands encrypted into S3, is encrypted in Redshift cluster, and their BI tool connects over SSL. And so it's unique, and if you kind of understand encryption, the key to encryption is really where does that master key reside at. And so there's many different options in terms of our key management service at AWS, as well as a hardware security module, either in AWS, but in the case of NASDAQ, they actually have this hardware security module which contains the master key on-premise in their own data center as well. So this really provides a level of assurance such that if there's ever any kind of vulnerability or breach or access to the systems, essentially it would just be access to an encrypted set of disks, and the master key is on-premise at NASDAQ, and so they can easily remove that master key from on-premise, and at that point the data, if it ever were to be accessed outside of authorization, would essentially just be encrypted data that is impossible to actually decipher. So the other benefit, and I'm just kind of go quick to leave time for questions as well, but is how quickly we innovate. So Redshift was launched about 3 years back. So it's still relatively new. Of course, its background is in Postgres, which has been around for a number of years. But the way that we kind of think about product development at AWS is this concept of a minimally viable product. So when we launched it 3 years ago, we knew that there were a number of features that we still needed to develop, but we didn't want to wait for the perfect system. We wanted to get it in the hands of customers as soon as possible, and then have our customers actually drive our roadmap in terms of development. And so we're essentially on a 2-week development cycle in terms of patches. So there's a continuous and automatic stream of new updates happening, and really the way we prioritize these feature sets is based on feedback from customers, and this allows us to be very flexible in terms of adding features that are most relevant to a majority of our customers, and then being flexible in terms of adjusting our development cycle based upon new and emerging requirements or large customer requests. So I just have 2 more benefits, but number 6 is it's powerful. So I mentioned that Redshift has ANSI SQL compliance, and we're always adding new additional analytic functions directly into SQL support within Redshift itself. But we've also introduced something called user-defined functions, and this allows you to write your own function in Python 2.7 and add that function directly into the Redshift cluster itself. So, one common example is if I want to do a URL parsing. Of course, I could do that through SQL with regular expressions, but that statement could look pretty ugly from a SQL perspective. So, excuse me. The option here is, one simple example could be, hey, let me write that URL parsing as a function in Python, submit that function to the Redshift cluster so that now I can simply call that function through SQL. As an input, I could give it the URL, and then it could return the actual individual components of that URL. There's also statistical functions that can be written in Python to really extend the analytic functions within Redshift itself. And because we're executing that Python code in a distributed fashion at the compute nodes, I can provide some very significant performance in terms of computational capabilities by simply leveraging Python as my user-defined function language. We also have very tight integrations with statistical packages like R and SAS, where your data set can reside in Redshift, but you can have your analysts use their statistical tool like R or SAS for more advanced analytics. And then the third one is, again, probably deserves its own hour kind of presentation, but we also have machine learning service from Amazon. So if you're not familiar with machine learning service, essentially it's targeted towards application developers that want to embed predictive analytics in their application, but not have to necessarily write and validate their own model. So there's about 8 different models that machine learning service includes that can be called through an API. And again, the raw data set can be in Redshift or it can be in S3. The machine learning, really provides that, application developer access to powerful predictive analytics with data sets residing in Redshift for that type of analysis. So benefit number 7, just kind of moving along, it's a large ecosystem. So like one of the first slides I showed was sort of that AWS view of big data services, but of course we know that in customer architectures there's going to be a hybrid mix, and hybrid can be defined as a mix of on-premise and AWS cloud, or it can even be within AWS, choosing the right tool set for data integration. So we have a great partnership with Informatica, for instance, where we have a connector for Redshift to be able to, if you have Informatica scripts that are written for, your current system, it could be as simple as, replacing your connector with the Redshift connector and, doing some light validations to make sure that everything works, but not having to completely rewrite your transformation logic if it's already in a tool like Informatica. Other tools like SnapLogic or Talend are also, popular use for this data integration. If I didn't want to use the primitive of the copy command to be able to load data from S3, there's a number of data integration partners that we work with. From a BI perspective or from the visualization side, I mentioned that Redshift looks like a Postgres database to any BI tool, but then we've also done specific certifications with the BI partners listed here, which just allows a certain level of assurance that we've validated the SQL that these tools generate directly against Redshift. And we continue to add both the data integration and BI partners as customers bring us new use cases. And then of course from a system integrator perspective or consultants, we have a number of partners. I'm sure something that you guys are very interested in is we go through a certification process where we have different projects you look at, and we have this big data competency which provides customers the assurance that partners have actually developed and been sort of validated against a certain set of projects within Redshift specifically. So the last benefit, and this is, I promise I believe it's my last slide before we kind of take some more questions, but this idea I kind of started off with is, how do we drive innovation through analytics, right? And so we know that Redshift is just, potentially just one piece. So, if you look at the use case of NASDAQ, they were facing a multi-million-dollar cost of replacing their on-premise data warehouse. They selected Redshift because it provided, still in a relational database, and it made the most sense for their use case initially. But over time, they found that, hey, there's other capabilities that actually can extend the analytic framework. And so they start leveraging Elastic MapReduce, which is our managed Hadoop service, because they were streaming this trade data, essentially stock trades, directly into S3 as a staging layer and then loading it into Redshift for analytics. And they found that for their price point and their kind of use case, that majority of their queries were looking at the last 2 years of data. So it made sense to store 2 years of data into Redshift. But then occasionally, power users, data scientists might want to look at a 10-year data set or a much larger data set. And so by leveraging S3 as their data lake and then standing up independent Elastic MapReduce clusters running Hadoop ecosystem, they can separate compute and storage and not have to store data into HDFS, where you have to 3x replicate the data, but singly store that data into S3 and then independently stand up EMR clusters running a SQL on Hadoop technology called Presto, provides that use case where yes, Presto, which essentially uses a Hive metastore, which queries data onto S3 directly, is, orders of magnitude slower than Redshift because it's not a columnar, data warehouse. But for that use case where cost is super important in terms of storing that 10 years of data on S3, and then when the question comes up, being able to spin up the EMR cluster that can query that 10 years of data directly against S3 becomes, pretty important to that use case. And so it's the idea that there's a set of additional services, you might think of them as products, but AWS, we call them services, that can augment your full analytic picture beyond just Redshift. And this is really where the benefits of just pay-as-you-go and cloud computing can really be advantageous for delivering a full analytic picture to our customers. So that's all of my presentation side. I guess I'll kind of go over to the console and see what if there's any questions. Otherwise, you can definitely chime in on the audio as well. Let's see. The question is, are we recording this? I think the answer was yes, we are recording it. We have one question. Does Redshift support any type of geo functions? So today, Redshift does not have a native geospatial data type. However, with user-defined functions, I believe there's a number of blogs that I can maybe respond back that you could forward on, where customers can achieve calculations between lat longs by leveraging Python code directly through the UDFs in Redshift. So, so sort of the answer, I guess, is sort of yes, but of course, that's something that we're keenly interested in on supporting, and understanding customers' use cases around that. But it's not a native data type within Redshift today, but there are some use cases where leveraging user-defined functions in Python can achieve those type of results. And let's see, I think that's all the questions from the chat. So I don't know if there's any other questions on the phone or on the audio you want to, I can help with. Okay, I'll take silence as no other questions.
Okay. Yeah, so actually, there was just one other question. Are there any resources our developers can access for help or assistance while they're developing? Yep.
So I think, a couple of sort of documentation links I would just point out, and happy to respond to the invite with those links specifically. But we do give a lot of thought to our best practices guide in our documentation. So there's best practices for data loading, schema design, query performance, and so understanding, I guess, the first step of that is kind of understanding the basics of, where that best practices guide is, I think is important. The second one, again, written resource, is AWS Big Data blog. And so this is where both our support engineers, our customers, our solution architects write not just for Redshift, but across the full big data stack, somewhat detailed explanations of how they solve particular problems. So for instance, one of our essays, our solution architects just wrote, top 10 performance tuning tips for Redshift. There's another article in there about how I can have a zero administration data loader into Redshift by leveraging Amazon Lambda with Redshift. So, monitoring and kind of updating and seeing, use cases on that AWS Big Data blog, I guess would be the second recommendation. And then the third, of course, is we do have a support forum, or AWS Redshift forum. So if you have an AWS account, you can log into the forum, and our Redshift engineers do monitor that forum and answer questions there. Then the fourth option, obviously, is, and one of the reasons why we wanted to have the call today was just to understand that, if you have a specific Redshift question, I'm more than happy to just send them to me, and hopefully we won't get 100 questions a day, but, where appropriate, we can, I can at least forward you to the question to the right person or answer it myself. And then, importantly as well, if you're at a customer site and you're doing a project and you have a specific problem you're running into, please let us know as soon as possible, and we're more than happy to have, one of our database engineers join a call, or one of our advanced technical experts kind of, troubleshoot and kind of work through this, learn from the SME type enablement. So I guess those are the four ways I would go about answering that question.
Wonderful, thank you. I'm sure that our developers will definitely be hitting those up.
Yep.
All right, so last call for questions. Okay, I think that we're good. And wow, we actually ended a few minutes early. So everybody can go back to their Fridays. Thank you, Greg, so much for your time and for sharing all of this wonderful information with us. We really appreciate it.
Sure. I hope it met your expectations. And, just like our product development is driven by our customer feedback, any feedback, if you think areas for improvement or things like that on my presentation today, please let me know. And we're happy to, learn from this hour as well. So I hope it was useful to everyone.
Yes, absolutely. Thank you, and have a great weekend, everyone.
Thanks.
Thank you.
All right. Thanks.